Hello students, today's video is over lesson 67, which is percent of change. So percent of change. In order to help us with this, we're going to go back to our old friend, the ratio box. Now since this is about percentages, we're going to make the first column, instead of ratio, we're going to make it percent, but the second column will still be actual, like normal. So when we use a ratio box for percent of change, we are always going to label this first row the original. And when we're finding a percent of change, all of our percentages want to be compared to the original. So the original will be 100% of the original, which should make sense. The original will be all of itself. So 100% right there always. The second column, or excuse me, second row, we're going to call the change. Those are going to be our change. And then in parentheses, we're going to put what kind of a change in it is it. So it's possible that this could be a change that's an increase, in which case we'll put a plus, or it's possible that this could be a change and be a decrease, in which case we'll put a minus. And so there'll be some sort of percent of change here. Since I don't know what it is, we'll just leave it as X. Now this percent of change is going to produce a new result, a new number. And so as far as the percentage goes, if it's an increase, this will be the 100% plus whatever X was. If it's a decrease, it'll be 100% minus whatever that percent of change was. So this is our basic setup for each of our percent of change problems. So we're going to take a look at a few examples together. So let's label this example 1 here. And for example 1, we're going to say that we're shopping and we see that something has a regular price of $42. But that item is on a discount. And the sign there at the store says that it is 30% off. So if it's 30% off, would this be an increase or a decrease? So if I come down and I set up my ratio box, my change of percent box, this will always be percent, this will always be actual, this will always be original, and this will always be 100. This will always be change. Now I asked you earlier, was this an increase or a decrease? Now we need to write in what it is. So hopefully you realize that off is going to tell us that this is a decrease. And so it's a decrease of what percent? Well, 30%, so we'll put 30 in here. So then my new, well, if it's 100% to begin with, and we take off 30%, that means that we're going to be left with, well, 100 minus 30 is 70. Now, the original price, the actual original price, was $42. So I'm going to put in my 42 here. The problem does not tell me how much it changed. It does not tell me how much the new price is. So I'm going to use X and Y here. Now, ladies and gentlemen, when working with a ratio box like this, remember that in order to use this to make a proportion, we only need 2 rows and 2 columns. Well, I've only got 2 columns, so I'm definitely going to use both of those. But with 3 rows, we get to ignore one. So I can either ignore the new row and use the original and the change to get my proportion, or I can ignore, let's see if I can get my pen there. It doesn't block it too much. I could ignore the change row to make a proportion using the original and the new, or I could ignore the original to make a proportion with the change and the new. So I obviously don't want to do this one because then I'd have two variables. Well, let's consider, what is the question asking? Well, that's a good thing to ask. We don't have a question yet. So the question that I want to answer is, what is the sale price? So in this case, the sale price would be Y. So we definitely want to use this row right here, and we definitely want to use the row where we know everything. So those are going to be the two that I'm going to use to make my proportion. So we're going to ignore the change row. So if I go ahead and make my proportion here, I'm going to have 100 over 70 equals 42 over Y. So in order to solve this proportion, we're going to cross multiply. Now, before I do that, I notice 170, it's a fraction all by itself. Let's reduce this real quick. Obviously 10 goes into both of these, so 10 goes into 100 10 times, 10 goes into 70 7 times, and that makes my cross reducing then a little bit easier in a moment. So now let's do our cross multiplying. 10 times y will be 10y, and then 7 times 42, I don't know off the top of my head, so I'm just going to go ahead and leave it 7 times 42. In order to solve this, remember we got 10 times y, so we're going to divide both sides by 10. And therefore, y is going to equal whatever this simplifies to. Now, you might be tempted here to take 42 and 10 and reduce before multiplying. I would actually recommend that you don't do that this time. And the reason for that is dividing by 10 is really, really easy. Remember that when we divide by 10, all we got to do is move the decimal over once. So if I think 7 times 42, you could grab your calculator, or you could do a little distributive property. If we think about 42 as being 40 plus 2, then 7 times 40 would be 280. 7 times 2 would be 14. Put them together, we get 294. Now, divided by 10, so slide the decimal over, and I get 29.4. But of course, what we're actually dealing with here is money. So when I put my dollar sign on, I will need an extra zero in order to have the two decimal places for money. So what is the sale price? Well, if it's listed for $42 with 30% off, it'll actually cost you $29.40. Of course, that's $29.40 before tax. So speaking of which, this leads us to example 2. In example 2, we're going to take our sale price, $29.40, and we're going to say that the sales tax, we're going to stay here in Michigan, where the sales tax is 6%. Now, just to be clear, 6% here does not mean that I'm paying 6 cents for every dollar. We're tempted to think like that because that's maybe what we were taught when we were younger, because it was just simpler to explain it that way. But when we say 6% sales tax, we literally mean we are paying 6% of $29.40, which means you're also paying 6% on the 40 cents. So if we set this up in our box, we'll have a percent. This is always actual. The original is always 100%. The change this time, so tax, does tax increase this or decrease it? Well, I think by now you've had enough life experience, you know tax is going to increase this. So we have a percent of change that is 6%. And then the new then, since this is increasing, 100 plus 6 is 106. So the original here is what we're starting with. We are starting with this $29.40. Now, since I'm leaving the dollar sign off right now, I can just write this as 29.4 for now. When we put the dollar sign back on, we will need to make sure that we have the proper number of decimal places. Now, I don't know these two, So I'm just going to put some variables in there, make sure they're not the same variable unless you know they are the same value. So I'll use x and y just to be traditional today. Now, just like last time, it's important to actually have a question. What are we looking for? Are we looking here for the change? The change here would be the tax. So how much tax we're paying. Are we looking for the new, which in this case would be the total price? Well, I'm going to ask you to find the total price this time. At this point, go ahead and pause the video, and I want you to try to work through what proportion would you make and try to solve it, and then once you've got it, go ahead and put play again and see how you did. All right, so here we go. I know everything in the original row, so I'm definitely using that, and I want to find the total price, so this is the new value. So these are the two rows I'm using. So my proportion will be 100 over 106 equals 29.4 over y. Now these are two different problems, so obviously this y is not the same as that y. Now I could reduce this before multiplying. I'm going to choose not to, because realizing that we're going to cross multiply, I'm going to get a 100y. Remember that 100 is really nice because we know eventually we're going to divide both sides by 100. 100 is really nice because we can just move the decimal over 2 times now. I'm going to leave that 100. On the other side, I'm going to have a 106 times 29.4. So if we divide both sides by 100, we can find our solution. So y equals, I wouldn't bother actually trying to mental math that. I mean, you could split these up and try distributive properties and things like that. But honestly, this is one where using our calculator can just be a time saver. So if you use your calculator, 106 times 29.4, divide that by 100, you're going to get 31.164. That is your answer. Now, of course, we're looking for a price, so this is dollars. And this is the part of the video where you should be saying, no, that doesn't work. We're not allowed to have 3 decimal places. However, you are going to show me that as the result of this. So at this point, I think you've probably already realized we're going to have to round this off. So if I round this off, I realize that this is going to be in between $31.16 if I just chop that off, or $31.17 if I round it up. So is a 4 closer then to rounding down, or is it going to tell me to round up? Well, 4 tells me to round down. So this will round off to 31.16 or $31.16. All right, let's flip our papers over. And I would recommend that you, again, pause the video, just take a moment to copy this down into your notes. All right, and here we go. So again, I'm going to start with my ratio box here. You know what, I'm looking at that and thinking about the numbers I'm going to put in. I want to make this a little bit wider, actually. That's a big number right there. So remember, the original is always 100%. The change here, you should have already read this for yourself. So a city has a population of 288,000 people. This is a 20% increase. So an increase means this is increasing by 20% from 5 years ago. What is the population 5 years ago? So the new then is going to be 100 plus 20. So this will be 120% of the original population. So if it has a population of 288,000 people, but this is an increase from 5 years ago, 5 years ago is going to be the original amount, which means this time I don't know the original amount. 288,000 is the new, which means we also don't know how much it's changed. So in order to solve this, I know everything in the new row, so we're definitely going to use that in our proportion. And we're looking to find out what was the population 5 years ago. Well, that was the original. So, making my proportion, I'm going to have 100 over 120 equals x over 288,000. So, at this point, we could do some reducing before multiplying if we want to. So I'm realizing if I, we could do some reducing, not before multiplying, just some reducing here. But realizing that we're eventually going to cross multiply, this time I'm not going to end up dividing both sides by 100, because it'd be 100 times 288,000. So you know what, I'm just going to go ahead and reduce these down. 20 goes into both of those, goes into this 5 times, goes into that 6 times. So now when I cross multiply, instead of having 120x, I've just got 6x. And on the other side, 5 times 288,000. We divide both sides by 6. Again, this might be a good time for a calculator. So if we throw this into our calculators, 5 times 288,000, divide that by 6, we're going to discover that x equals 240,000. Well, of course, this is a distorted problem, so 240,000 what? 240,000 people make up that population. And ladies and gentlemen, that is lesson 67.